Hello, everyone, and welcome to another Into the Terminal. Today, we're going to be talking about weird bashisms.
I'm muted. Sorry about that. Weird indeed, because Bash is full of all kinds of, weird symbols and weird whatevers that you learn as you go, unless you're one of those fanatics who likes to go read all the man pages. But if you didn't, you can just watch today's show.
Well, I don't know about that now, but
No, we're going to be as exhaustive as the man pages. That's the goal today.
Exactly.
Buckle up, everybody.
But a lot of times, because our keyboards only have so many characters, a lot of them will end up doing double duty in scripts or command line or context appropriate usage. Like there's times where characters mean different things, and maybe a double character of the same character means a different thing. And so today we're going to jump in and kind of start looking at what that means and how it's used.
All right. So should we go ahead and get started here then?
Yeah, let's do it.
Here we go. Come on. There we go.
All right, so we're looking at a RHEL system here, and I've already written a shell script for us to do in this first example. So let me pull it up, and we can take a look at it. All right, so I've turned off syntax highlighting to make it a little bit easier to read. And essentially what I'm doing is I'm running a series of commands. We'll cover the semicolon in a couple of characters. But what I want to cover is that thing in parentheses. So parentheses is one of those characters that gets used a bunch of different ways. And here, what we're doing is we're saying that this series of commands that I have enclosed in parentheses, we want to run in a subshell. So when you run a script, generally, it creates a subshell for the purpose of executing the script. And what we're saying here is that we want that subshell that the script is being executed in to create another subshell for running this ls command and the stat command. So let's run it and just kind of see what happens. So it executed, no errors, that's good. And if we take a look at temp log out, which is where it was writing all of the data that came from this series of commands, here's the output of those commands that we ran in our script. Because outside of the parentheses, I used a redirect operator to say, run these commands in a subshell, and then I'm going to take all of the output and errors that happened from that encapsulated series of commands. I'm going to put it in this log file. And so if this one of these commands generate an error, we'd see that within the log file. In fact, let's make that happen. Let me put something in here like cat, a file that I know doesn't exist.
There you go.
All right, so now when we run it and we take a look at it, or its log output, right? So here's the output of my ls with all these different files. And then there is the error message that got generated out of that middle command. And then here is the stat command that ran after the cat that generated the error. All right. So I use this a lot in scripting when I want to run a series of things and then take all of the data that's generated by that series of things and treat it as one string or one unique element for working on later. So I encapsulate the things that I want in a subshell and then send it off to a piped command or grep or whatever, or in this case, redirect it to a file for use later. But there's something else that's unique about doing this. And we'll go into a lot of detail about this next week when we talk about profiles and RCs. But one of the
You're
things
getting
that
ahead of
happens,
yourself here, Scott. We don't talk about next week's episode till the end of this episode. Now, come on.
shocking that we even know what next week's episode is. But one of the things that happens in a subshell is variables, whether a variable is there or not there in the subshell, right? And so when you create a variable, you can mark it for exporting, which then passes it to child processes. So what I've done, and actually let me edit my script first, and then I'll show you what I've done. All right. So if I echo $floof, right, I've created a local variable named floof, and I put a string in there as its value. And that exists in my local shell. But I have not exported it to subshells. So in my script, I said, okay, we're going to run that ls, we're going to run that cat, that's going to result in an error. We're going to stat a file. And at the end, I said run set. And set shows me all of the environment variables set in the shell environment that we're currently operating in, which, because it's enclosed in parentheses, we know as a subshell. And so what I'm expecting to see is when we look at that set output from this isolated into a subshell process, I should not see floof because it was never passed along to that subshell as one of its exported variables. All right, so let's see how that goes. All right, so there's my list, there's my stat, and then down here is my list of variables that are in the environment that was executed from the script. And if I search for floof, pattern not found, right? But we can still see here that it exists in my originating shell. And so that's another reason why you might want to execute a bunch of stuff in a specific subshell, is because then you would ignore all of the weirdo environment variables that might exist in your current shell. And instead, you only get that list of exported variables for your subshell process, which also might cause other problems, because if you're expecting a variable to be there, it may not be there because you didn't export it. But it basically makes it so that you have a clean environment to execute stuff in an isolated subshell. All right, so that's what parentheses does. Oh.
You're only halfway through, and we're what, 8 minutes in. Come on, Scott.
Jeez, it's critical path. So we see parentheses other places too. So for example, we see parentheses used in maths. If I could type today.
That's why we copy and paste, Scott.
Details. All right. So what we're doing with the double parentheses is we're basically saying, I'm going to do integer expressions in here. Because it's in double parentheses, it allows me to do some interesting things, like I can reference variables or set variables. And because it's in double parentheses, and this is something that's unique to Bash and a couple other shells, it'll figure out what I mean with these commands in these double parentheses. And I need one more space right there. All right. So what I did in those double parentheses typically mean that I'm going to be doing some kind of, or double parentheses mean I'm going to do some kind of math. And here I actually made a variable assignment inside of my mathematical expression. So not only did I multiply 5 times 3, but I also set this variable, right? So if I do echo $maths, right, I see the result of that assignment. So double parentheses, I'm going to be doing integer mathematics, and maybe even also doing some variable assignment within it. But wait, there's more. You may have also seen, all right, you may have also seen dollar double parentheses. So Oh, and I do have one more double parentheses example. So you could do
Yeah.
something like this. You'll see this in maybe in looping.
Yeah. I use this a lot in many different languages just to keep track of how many iterations of a loop you've gone through.
Yeah. And so here, like count as a variable reference because it's in double parentheses. I don't have to use a $ or other dereferencing characters. And the plus plus, Bash interprets this and goes, oh, you mean count +1. It is able to recognize the expression that we have and do the right thing. All right.
And many languages treat that differently, but this is how Bash does it. And a lot of languages do the same thing. Variable name, plus, plus, done.
Yeah. All right. So double parentheses. Last piece before I turn it over to Nate for the next craziness. All right. So double parentheses works a little bit differently. So we might say something like this. So here, double parentheses says that I'm going to be doing some maths, but instead of just executing the thing, I want you to contextually execute the thing inside of a larger string or command. So I was making my variable assignment, and then instead of giving it a number or a string, instead I gave it a mathematical equation to execute first, and then take the result of that and assign it to the variable, right? So if I do an echo $result, right, that's what we see. You can also use this for embedding mathematics inside of other things, right? So we could do something like this. So when the shell is parsing this command, it sees that $ reference and says, okay, I'm going to pause doing the echo thing, and I'm going to instead resolve this expression 3 times 5, and then I'm going to take the result of that expression, I'm going to substitute it in the same spot within this larger command in which it's embedded, right? So what I expect to see out of this is the result of 3 * 5 is 15, period, right? So this allows you to embed a context-aware execution inside of a larger series of commands that you're running. And we'll see this a couple different times. I know that Nate is going to talk about $parenthesis, which is for embedding subshell execution commands inside of something else. We'll see, I think there's another $ in a character and does something very similar.
There's $curly braces we'll be dealing with, $parens. There's a few.
Yeah. All right. And while we're here, do we want to cover curly brace, just regular curly brace?
I mean, we're already going out of order, I think. So, go right ahead.
Okay. Then. Well, the reason I brought it up is because it's kind of similar to parenthesis. I know that, Nate, you have some additional curly brace stuff in a bit.
Yeah.
But I wanted to go back into my script. One day I'll edit my vimRC and turn off syntax highlighting.
Yeah, but then the next time you spin up one of these temporary labs, it's not going to be there, so it won't matter.
That's true.
You'll have to do it every time we prep for the show.
Maybe I will. All right. So here I just changed that parenthesis, which remember we said was to take this series of commands and execute it inside of a subshell as a clean environment. And I just replaced it with curly braces. So from a, what does this thing do? It's not going to appear to be any different. Oh, maybe it is. Notice it didn't honor my redirect. Because instead of running everything inside of a subshell, instead, what it did was it executed the series of commands inside of my current shell environment.
Okay.
And because it was executing inside of my current shell environment, things like how the command line was parsed was a little bit differently. And that redirect did not get honored. And I ended up getting stuff on my console output.
For some reason, ls didn't work.
Oh, that's because I have I didn't put in a space. Right. So if I do that, whoop, man, dollar, there we go. And make it easier for it to read. And I probably should put in a space over here too.
After this set, yeah.
Which isn't really needed because that's the end of the, it's a character that the shell will parse and understand at the as the end of the set of commands.
It still makes it more readable though, I would argue. So probably a good habit to be in.
Oh, no. Now I'm like going off the rails.
Now you've totally broken it. All because I noticed that ls didn't work.
Why, Nate? Why?
Because I like to see what happens when your scripts don't work properly.
Just like making problems. All right, let's try it like that.
Isn't that what you did the first time?
It is, and still gets me an error message about the ls command. I think that's because
that's weird.
It's a weird dereference, right? And you'll actually be talking about curly braces with variable references in a bit.
Yes,
and I think it has something to do with that. But now that I've taken us off the rails and down into a crazy rabbit hole, we'll just change gears entirely.
Yeah. Well, you had ampersand for backgrounding and double ampersand next on the list, and that kind of leads into the first thing I was going to talk about anyway. So, do you want to touch on that quick?
Oh, dear Lord, that's a lot of Scott.
It is,
sure,
but we'll have two or three that are mine after that, so we're good.
Okay. So ampersand and double ampersand. All right. So let's run a command. And Nate, I'm gonna take your advice and I'm gonna copy and paste. Maybe. All right. So I'm running this command and it's doing 100 gigs of data transfer between two devices. And it'll end up taking about 13, 14 seconds to do this, but it runs a long time. And so one of the things that is common to do for long running processes is to put it in the background, or basically have the shell continue to operate it, but return my command prompt to me so I could do other things while that long running task is sitting there in the background still executing. All right. So to background a job, ampersand, and there we go. And it gets a job ID, job ID 1, and it tells me the process number that it backgrounded. And I could do things like PS, grep for D, whoop, and it's done. Let me try it again. There we go.
Make it
PS, AUX, grep.
Type faster, Scott.
D. Oof. All right. So
too many things with two D's in them. There it is.
It was right there. Right. So it was back there running. And if I kick off one more, if I do jobs, this shows me all the programs running within this shell. And we can see that this DD is back there running in the shell, even though I have my prompt and I can do other things like jobs or ls or whatever. Right. And then when it's done, it prints its output and exits.
Right.
So ampersand is how you background a job, right? Run it behind the background of your shell.
You can get that back to the foreground if anybody accidentally put it in. If you ran a thing with an ampersand and you're like, boy, I really wish I could see what's going on. You notice when you ran that, it gave you a number, not just the process ID, but that 1 in brackets there. Yep. If you did an FG and then 1, it'll bring it back to the foreground.
And isn't it FG %1?
That may work. I don't think I did it with the percentage in the past, so I think it works either way. But Could be wrong. It's been a while.
Well,
But
let's try without
if-
the parentheses.
If anyone's curious, how do I get that thing back to the foreground? That's how you do it.
Oh,
There you
it
go.
works without the percentage.
There's also a
That may be
BG
a-
command, but
Yep.
if we don't have a demo planned for it, I'm not going to ask you to remember how to use it.
Well, here, we'll just do this. And then FG1, and then we'll Control Z.
Oh, and then BG. That's
stops
how it
it.
works.
Yep.
Yeah.
See, this is what I should have done in the beginning: is stop the job, and then I could have PS'd it and like all the other things without it having to worry about it.
See that?
All right. So when you have a job running in the foreground, and for whatever reason you decide that you want to move it to the background, you can hit Control Z, and it will stop the job. Right, and you can see we're looking at the jobs queue here that the state is stopped, and then I can resume that job. And I can either resume it in the foreground or the background, right? So I can say FG %1. That's the POSIX way to do it.
Okay.
Or I could say BG %1, and that'll put it in the background, right? So you tell it whether you want to resume to be the controlling process in your shell, or you want to put it in the background of your shell and running back there, right? Jobs, right? So it's back there running until it's done.
Which this is all super helpful when you're at a console and you don't have multiple terminals to deal with, right? Like if you're on any modern system where you can just open up another SSH session, it really doesn't matter. You could just make a new one and let that one run in the foreground. It doesn't matter. But imagine the days when you're physically sitting at a terminal and you're like, boy, I'm stuck. I can't do anything right now because this job is running in the foreground. You could then background it, let it run in the background, and then do something else. Or use tmux. Yes, there's a bunch of ways to get around this now, but it's still such a useful thing that, of course, it stays. So,
all right. So I noticed Shantanu said DD status equals progress. I'll do you one better, Shantanu. So I added a 0 to this to make it run much longer. And so it's running, and you don't know what it's doing. You can just do a kill -sig user1. And its process ID, and it will send me a status of the DD command that's running, right? So anytime you're running DD, there's actually a signal catcher for SIG user 1 where it'll output its current status. And so as I keep running it, you can see it's like further down the hole of writing however many gigs I told it, right?
Until it fills up your disk and ruins all the rest of your demos because your machine gets cooked.
Yes. Yeah. Well, and then how about we do this? Kill %1. Boom. Now it's dead.
Away it goes.
So kill by job number instead of by process ID.
So murderous.
All right. But we wanted the other thing, right? So ampersand puts something in the background. That's cool. But then we'll also see double ampersand use places.
Right.
And double ampersand does something completely different. Not at all related to backgrounding and job control.
Which is not confusing at all.
Right, exactly. All right, so let me exit my tmux session here. There we go. So I have a directory of stuff. Oops, start. All right, there's a whole directory of stuff. And I might want to only do another command if this directory has something specific in it, right? So I can ls tester foo3 star. And if this fails, I don't want to do anything more, right? But if this is successful, I want to also run a stat on this one file, right? So double ampersand is essentially a logical and that says run the first command, and based off of its exit status, right? Did it complete successfully or did it not complete successfully? If it completed successfully, also execute this secondary command, right? So there we go, right? So it successfully printed out the foo 3 stars. And then because it successfully found those files, it went ahead and did the stat. All right, but if I change it to make that first command fail, notice that the, whoop, let's try this. There we go. So I made the first command fail because I ran a non-existent file to ls, right? We could see that error message come through in the output. And because the first command in that list failed, it then did not execute anything further on in the list, right? So double ampersand is a conditional execution. If the first command succeeds, then run the secondary command. And you can actually do a string of them. So it's like if the one before succeeds, then do the secondary one. And if the one before that succeeds, then do another one. So you can keep going if you want to do a series of logically ANDed things.
And I've got a couple other sort of like command stringing and whatnot commands to go through. So we can switch back to me. Are you going to do it? I'll do it. Here we go. So I don't know what happened a minute ago. It's like Restream hiccuped and all of like I went away and came back. That's why I vanished and came back. Okay. So Scott showed us he showed us one great way to do one command and then the next one, right? And I've got two more lined up. But the first one is, what if I just want to munge a couple of commands together without caring how the last one exited, right? So you can just replace Scott's double ampersand with a single semicolon. That basically says, it tells Bash, on this line, I would like you to run this command and then run this next command and then run this next command, right? So that's pretty simple, right? We can just do, here I have a quick example here. We're just going to do an ls, right? So you do ls once and it does the thing. PWD once, it does the thing. What if I wanted to run them both at the same time? Or not at the same time, one right after the other, right? If I put a semicolon in between the two, it'll run one and then the next. Now, the difference between this and Scott's example with the double ampersand is if the first command fails, like if I do an ls/blah and then do a PWD, it's going to just give me the error and then it's going to do the PWD because it doesn't care, right? It doesn't care that the command before failed, right? So this is commonly used if you're doing stuff like, I don't know, loops or logic right inside of Bash, like right on a command line. So I use it very frequently with like a for loop. If I did it like a for I in, I don't know, foo and bar, and then a semicolon, because that's, if you were writing this in a Bash script, normally you would then go to the next line, and then you tell it what to do inside of the loop. We're going to do echo, and then you'd normally go to the next line, and then you'd say, okay, my for loop is over, done, right? And then Bash sort of assumes there'll be a semicolon at the end, but because it's the end of the line, we don't have to do another semicolon, right? If I hit enter, then it's going to execute that script. Scott vanished for some reason. Hope that's okay. So that's commonly why you would use a semicolon instead of the double ampersand. But there's two more things I wanted to show you. One's related to what Scott showed earlier, and the other is, well, these are two commands that, again, are a little confusing. We've got pipe and we've got double pipe, which, again, totally different effects, totally different things go on with these two things. Pipe is a really common thing. If you're a systems administrator and you've spent 20 minutes at a command line, you've probably found the value of piping the command output from one thing to another. And that's exactly what pipe does. So I cooked up a quick example here. We're just going to I usually use this for log parsing. It's one of the, I'd say far and away, the thing I've done most with command line, with piping, is get the output of a bunch of text and then do something with that text. I want to filter it down or I want to redirect it somewhere or whatever, right? So this is just the raw output of all the stored var log messages on this test machine that I've got running here. Obviously, I can scroll through that and look for something, or I can try to filter stuff down by using things like grep and sed and awk. And there's lots of other reasons that you might use pipe, but I'm going to give you a quick. So we're going to say, all right, I've got all the var log messages. Maybe I only want var log messages from today, right? So if I do grep feb 13, and maybe I want like a specific time. 10:39 is what I put in my example because I know there were some log entries from 10:39. Okay, so now what this is doing is it's taking all that output that it just sent to the screen to standard output, and it's redirecting it through grep, and grep is looking for this specific text string, right? Now, and you can use, this isn't a how-to on grep, right? Because there's a bunch of stuff you can do with grep, regular expressions and whatever that are a lot more sophisticated than grepping for a specific string, date, time, and minute. But I digress. Okay, so now we've got it. It's showing us just the log entries from February 13th at 10:39, which is a lot more manageable. We've got like, what, half a dozen log entries here, which is cool. But now I can redirect it again or pipe it into something else. And in this case, you may have noticed that this machine is called ITT 174, but we're not on ITT 174. This is ITT 176. So we're going to use sed to fix that. See if I got those typed right. Looks it. Okay, and now the output is going to correct that ITT 174 to 176. Again, a sort of a contrived example, but the point is that you can, this redirection and piping is super powerful when you're trying to just manipulate the output of text. Now, on the other hand, we've got the double pipe, which is a logical OR. Okay, so you saw what Scott was doing earlier with the command line out. You would run a command, and then the double ampersand would say, if that executed successfully, then do the other command. Well, you can do the same thing with OR, except I have a much simpler example here. So you're familiar with the true and false executables within Bash. One will do a return code of 0. The other will do a return code of not 0. So true will return like, yeah, I did the thing. False will return, I did not do the thing, right? So if I do true and then I tell it to do this other thing through double pipe, echo, you should never see this, right? Because what this says, or essentially comes down to, if you get a return code of 0, don't do the next thing. That means if the first command succeeded, don't do the second one, right? Now, you could imagine maybe you've got a script that does backups, and you have some contingency that says, if the backup failed, I want you to tell somebody, or I want you to run this other thing, or I want you to do something so that our backups did not just silently fail, right? That might be a great example of where you would use this kind of thing. So now you should see it did nothing because I told it true. True, of course, succeeds because that's what true does. And then it says, and if that doesn't exceed, do this other thing, which should never happen because true should always succeed. Now we can reverse that with false. We do false and then two pipes. Echo, you should always, like a type, see this. Okay, and of course, there we go, because false returned something other than 0, and then the logical OR told it, okay, do the next thing, and the next thing was just to echo, yep, you should always see this. So another example of, single pipe does one thing, double pipe, completely different thing. All right, we have any questions? Or I see there's a bunch of chat going on, which is cool.
Oh, we were just, Rick and I were both bemoaning your use of cat to grep.
I know you can just use grep directly, but come on, like I said, example.
Yeah. And we both picked up on that. So Craft Z7T put something in that was a combination of ampersands and pipes. And he's like, I know it works like an if, but I don't know why it works like an if. So I can put it on mine.
Yeah, let me switch over to yours because I'd have to go find it and then try to recreate it.
Yeah, so this is what he put in: true and true or false. He's like, it works like an if, but I don't know why it works like an if. And it turns out that what you're looking at is actually a weird method of parsing this. So the thing at the beginning, the command at the beginning, if it succeeds, then it runs the thing on the other side of the double ampersand.
Right.
Right. But the thing on the double side of the ampersand is an or. So it doesn't run true, true, or false. It runs true and then true or false. So if the second command fails, it runs the third command. But if the second command is successful, it doesn't run the third command. And so this is because logical ands have a higher precedence than logical ors when parsing the command line. And so to put it a different way, this is probably more explicit, right? We run true, and if that succeeds, this other thing gets run, right?
Right.
And so you can actually control the precedence of logical ands and ors by subshelling parts of it. So we could say something like this. So here we're going to run the true command, and if that's successful, then we'll run the other true command. And if either of these fail, then we'll run the false command, right? So because I'm using the parentheses to explicitly define what thing should be done with what other thing, I can more easily understand like why something gets triggered versus when something doesn't get triggered. So without any parentheses, I think you're relying on someone knowing how the shell is parsing this to know which one is being executed first or second.
Okay.
Yeah, so the other one that we wanted to talk about was square bracket and double square bracket.
Yep.
So we've been asked this one before. Let's see. So in, oh, actually that won't work. Hold on. No, that'll work. Okay. Square bracket is a command, which is the same as the test command. And essentially it's looking for this thing that's inside the square brackets to resolve to a positive or successful output, right? And so let me control C this for a second. Oops. Right, so notice that when I say which square bracket, it says user bin square bracket. Right, it's actually a command called square bracket. There's an executable called square bracket. And this is the same as the test command. So it's usually used in things like if statements in scripting to test a condition, to then decide whether you want to do something else, or maybe check something else with an if else or else if, or do something else with an else statement. All right. But then double square bracket. All right. First, you'll notice that unlike square bracket, there is no executable called double square bracket. Instead, it is a bash shell built in. And there are a couple other shells that also have it built in. I think corn shell is another one. There may be one past that. It works in a lot the same way as square bracket, right? Where you're wanting to test the result of something to determine whether you then want to do something else. Except because it's a bash shell built in, different rules for parsing what's inside of it apply. So if you use square bracket, single square bracket, you are using the POSIX test command. And inside of it, if you're referencing a variable, has to begin with a $sign. If you're using less than or greater than, you can't use the symbols, because in Bash world, the less than and greater than are redirect operators, not comparison operators, right? But in double square bracket, the Bash shell changes the rules for how it parses things. And so you could do things like use less than and greater than operators to mean a comparison, less than or greater than. You can do things like assignments, variable assignments. You can reference variables without their $sign, and Bash will figure it out.
Yep.
The other big thing that is often recommended for using double square brackets is variable expansion, right? So in my test, the recommendation is that when you use variables inside of double square bracket, you have to enclose them in quotes. And that's because if this variable contains multiple space-separated things, without the quotes, it substitutes multiple space-separated things, which the Bash shell then interprets as a whole bunch of different things, right? Because the space character is the delimiting character when Bash is parsing something to know how to break it apart to look at each individual component, which Bash calls words, right? So it looks at the space character to figure out what words are in the command, and then it looks at words to see if there's something special like greater than or less than, which are redirect operators, and can make a bunch of Bashy changes. So if you're using just regular single square bracket, it is always recommended that when you use a variable, you put it in quotes, because then if it gets substituted and it's substituted for space separated things, Bash doesn't misinterpret that as more words that it needs to look through. All right. But if we go to double square bracket, like this, it functionally works the same. In fact, we can also do things like this, where Bash will take care of going, oh, because it's in double square bracket, this is not a variable assignment. It is an equality operator.
Right.
And it'll parse it differently so that if floof is actually a series of space-separated words, Bash will treat the resulting space-separated words as a single entity when parsing this command, right? So instead of it being broken down into multiple words, Bash takes a second pass at figuring out how many words are there and what the words mean. This happens after the initial Bash syntax passing. So double square brackets is the recommended way in Bash for doing things like tests and other things, because you get this additional benefit of how Bash parses, some additional syntax flexibility, some environment variable or variable protection, so that the content of the variable doesn't get misinterpreted as a series of additional things for Bash to do. So that's the difference between single and double square bracket.
Shantanu doubts your use of equal versus double equal here.
Well, let's see. Actually, let's do this because it was set to 4.
There you go.
It did not.
So it didn't set it. Did it do the evaluation properly?
It did the evaluation, but they're not equal, right? $floof was nothing, and that's not equal to bar, so it didn't do anything. In fact, if I look at that and then echo $? Right? It didn't exit successfully. It exited with a non-zero exit code, meaning this comparison failed. All right.
I was looking through chat to see if there's any more gotchas there. Okay. I think we got it. Are you relieved that it worked, Scott?
Woo. Live reaction to Chantenou. There we go.
Yeah.
Somehow it
Yeah.
worked.
Okay. All right. So I think the next one's mine. Let's switch us. There we go. All right. So where am I at here? This one's another one that's really common, and this is output redirection, not piping, but actually redirecting the output of one thing to another, right? And there's two directions you can do this. There's redirecting from the output of one thing to the input of the next. And then there's another one where you can pull it from one place back into the command you executed. And to be honest, well, let's just start from scratch here. So we're talking about the greater than and less than symbols here. So the easiest thing here is if I echo something, we'll just say the word test, and then of course it puts it to the standard output. I can then redirect that output to something else, right? Okay, and now if I cat my file, it should say test. Okay, simple as that. Now the single greater than symbol there will overwrite what's in there. So if I did test foo to my file and I cat my file, it just replaced whatever was in there with test foo, which is sometimes like you got to be really careful with that because it will unceremoniously overwrite whatever you just directed it into. It doesn't really care what it is. If you've got permission to write it, it will clobber the file and put test foo in the file. So you got to be really careful when you're using this sort of output. If that was like a log file or like an executable because of a typo or something, or I don't know, a virtual disk file, it will now be gone. So be careful. So that'll override the file. You can also add to the end of a file by using double greater than, right? Let's go something a little bit bigger here. Let's go like cat etc password or something that has some data in it, and we put it into my file. Now if I cat my file, not vat, cat. If I scroll up here, at the top of it, you'll see test foo, because that's what I put in there initially. And then the rest of it, we see the output of etc password, right? So that's all fun, right? And this is something that gets used, I mean, I would say a bunch. There's a lot of use cases where you want to take the output of one thing, put it into a file, right? Maybe that log output that I was parsing earlier, I need to save for something. I would just, once I got the output that I wanted, I would then redirect that into a file as my last redirection, and boom, it's now saved to a file, which can be really helpful sometimes, especially if you're doing this in a script where you don't have it right in your terminal where you can then just copy and paste it out. You have to save it for some reason or send it somewhere. You can send that to mail and mail it off to somebody. You know, there's all kinds of good reasons why you'd use that. Now, the one that, again, is very helpful, but maybe has less use cases, is the less than symbol. And what this will do is it'll take the contents or whatever of the thing that's on the other side of the less than symbol and throw it into the command that you ran. And a really simple example of this would be something like sort. Okay, so let's cat etc password again. And again, this is contrived. Somebody's gonna quickly tell me there's no reason to do sort this way, but it's for the purposes of showing you how this works in a simple way. Okay, so I've catted etc password, and you can see the output of etc password, right? It's not alphabetical. It's not in any specific order other than how these users were created when the system was built. Okay, so now if I were to clear the screen and use, just say sort, and then the less than symbol, and then etc password, what this will do is it'll take the contents of etc password and send them into sort. And now you can see they're alphabetically sorted, which is the default thing that sort will do, right? So again, I could have just done sort without the less than, and it would have gotten me literally the exact same result, but you get my point here. This, I have most commonly used this when I'm doing something like restoring a database dump, right? If you want to, at the command line, take a SQL file from like MySQL or something and pipe it back into the MySQL client to restore a database, that's where I've seen this used most frequently. But there is a slightly more, I don't want to call it advanced, but a really good use case of both the redirections at the same time, and that's commonly referred to as here doc. We use this a ton when we're setting up for these labs because we work out these things days, hours, whatever in advance, and we put them into a doc somewhere. And then we need to run them quickly before we get ready for today's, for the show. Or if you're running a script where you need to write something or whatever, you can use here doc to take the output of a script and put it into like a text block and cleanly put it back into a file later, right? So I'm just going to copy paste. Hopefully my copy paste isn't broken here. So you can see I did cat, and then I did this redirection and the token EOF, and I told it to send it into this file.txt. And then I put some text, and then at the end of it, I put EOF, right? Now that tells the here doc that that's the end of what I wanted to put into the file, right? So this should put all that data into file.txt. And there it is. Thing one, more things, and lots of other things now live inside of my file. This is great for if you've got like the output of a script that you want to write in place in an automated way. Here doc is a great way to make that happen. Okay. That's what I had for greater than, less than. Scott, we're running out of time. What do we need to drop? We were worried about this. Here, I've got a quick one. Sorry,
I say let's just do one more.
One more?
Yeah, just one more.
Man, now I got to pick the best one. All right. Well, the best one I'm gonna pick then is, because we've had this conversation on the show before, and that is dollar open and close curly braces versus dollar open and close parentheses. Okay. And we're also going to talk about backticks because that's come up on the show before. So what we're talking about here is this versus this. Okay. So how are these interpreted by Bash? And I've got a couple of examples here. So we're going to start with the curly brace one. With the curly braces, what this does is it kind of hard defines the variable that you're talking about. So if I set a variable, not dollar, I do like var equals my data. Okay. And then I did echo dollar var. Then there we go. It gives me my data. But what if I did echo dollar var? What if the output of whatever's in var, I'm trying to put inside of some other text or put inside of a command, for example, right? If I do like $var dash test, it worked. See, it did my data dash test. But if I do $var underscore test, it gives me nothing because it tried to expand $var underscore test as the variable name, which doesn't exist, right? Now the dash, it treated differently. It treated $var as the variable name and dash text as, or dash test as text after the variable name. Now, how Bash decides what it does where, I'm not going to say I have like this lexicon of where all the places where this is dangerous is and where it's not. But a good way to make sure you're safe is to include, instead of just $var, do dollar curly braces like that. And what that tells Bash is here's the beginning and end of the variable name. Now you can use that anywhere. It doesn't have to be inside of something like this. I could have used it when I did echo var up there, right? And that way you're sure it's going to be treating it properly, right? And there we go. Now it's interposed in just the right way. So if I'm writing a script or if I'm writing a complicated command line argument or output that uses variables, I will usually default to trying to use the curly braces unless I'm absolutely certain I don't need it, right? So if there's any question in my brain, I'll use those curly braces because I think it's safer. All right, anything on curly braces before I get into the parentheses? All right, so we'll cover parentheses and backticks at the same time because that'll save us some time and it will answer some questions we've had in the past. So dollar curlies is one thing. Dollar parentheses is actually, what it'll do is it'll grab the output of, like I said, we're talking about this. It'll grab the output of whatever is inside of those parentheses and substitute that wherever you put this, right? So if I did echo dollar and I put ls in there, it'll run ls, and then inside of my echo, it'll give me the output. So if I did something more like echo, just trying to give you a better example as to why the heck you would care, because you could just run ls and it would give you the output. Right. So now I put some text and it says, here's the output of my directory, and it formatted it differently because I put it inside of the quotes, I think is why it did that, in case, because I know someone's going to ask, why did it format differently on the second try where it did on the first? And this can be really useful if you're writing a script that has to get the output of something, like echo the date is, right? It'll give you the date. Of course, I could do more with date, change the formatting, whatever, things like that. And that's really handy, I think, right? It's really useful, really helpful. Now, there's another way to get the exact same thing done. Like they're literally interchangeable. And that is to simply replace these with backticks. Right? Does the exact same thing. So the question that's come up a number of times on this particular show, because I usually use backticks unless I don't think I can get away with it. Then I'll use the dollar with the parentheses. They're pretty much interchangeable. However, there's a couple reasons why you might not use the backticks. And some of it comes down to preference. A lot of it just comes down to which one is more convenient to use at the time. The conversation we've had on this show in the past, I see Scott getting all, hold on, let me finish. One thing is keyboard layouts. Sometimes the backtick key is just really hard to get to, or I don't know, maybe some international keyboards don't even have it. Do they? I don't know. Maybe there's cases where it doesn't. But sometimes they're just hard to reach. That's the feedback we've literally gotten on this show, right? So that's one thing. That's more of a personal thing based on your keyboard, your fingers, whatever. But the other thing is escaping. So with dollar parenthesis, it's really easy, and hold on, I have an example here somewhere, to take one output or I should say take more than one output and combine them into one command. And here, clear the screen here. We'll paste this in. So I've got, we're going to use echo again. It's my favorite example. We're going to do dollar parenthesis file, and then dollar parenthesis which Python 3. So it's going to find Python 3, the binary for Python 3, which Python 3 is going to return the path, and then we're going to run file on it. And if I hit enter, it's going to come back and say, that's a symbolic link, which is exactly what it is. If I were to go find Python 3 and show it to you, that's exactly what it shows up. Now, with backticks, that's not as easy. If I do backtick file, and then another backtick, which Python 3, and then 2 backticks because I have to close the first one and the second one. You can tell already this isn't going to work because I've closed the first backtick after file, and then I didn't really open another one. I just closed with 2 more backticks, right? Because it just doesn't know how to treat that. So what you have to do is within the first backtick, you have to escape the second backtick and the third backtick, and then close it with the fourth one. And this is just a mess, right? It gets really nasty and confusing, but it worked, right? But if you did dollar parenthesis instead of backticks, then it would be a lot easier to type, really is what it comes down to. Now, Scott, I know you're dying to tell me whatever you were going to tell me. Go ahead.
Well, I think you covered it. Dollar parenthesis is the way to go. Backticks not. A whole bunch of reasons. One, keyboards, right? So your international friends who may be trying to edit a thing after you may find it very hard to find the backtick character on their keyboard to do something. But the other thing that you just highlighted is bash syntax parsing. Right. So bash knows how to identify an open parenthesis and a closed parenthesis. And when you use multiple open parentheses, it knows how to kind of level down and parse the individual things underneath that have been embedded within another string. But backticks, nope, doesn't know how to do that. So the reason it failed was because when you closed your, essentially it thought file and which was the enclosed command. Right? And then you had an empty enclosed command at the end because it didn't know how to parse, what do they call it? not combined, but it didn't know how to parse embedded backticks within other backticks. And that's a function of the bash shell and how the bash shell parses commands before it runs them. So the other thing I would like to point out for backticks is when you copy and paste them, they are extremely hard to identify. Like, is it a single quote? Is it a backtick? Or in the case of your like formatted docs, is it a forward-facing curled quote?
Right.
Yeah, so just $parenthesis, you don't have those types of problems when you're moving around different formats.
You run into that a ton. We do anyway, because we make the notes for the show in Google Docs because we want them in a shared place that we can both access them. And Google Docs is horrible, and I mean horrible, about replacing characters with things that it thought you wanted to put in there, like changing double quotes, changing the direction of quotes so they look nicer, and it just totally ruins Bash. It just you try to copy and paste and it doesn't work. You've seen the copy paste fails on the show, but Backticks is one of those. All right, and really, we only had, I think we skipped two. One of them is the escape character, which we've used all over, but we didn't talk about. And the other is sequences within curly braces. So like a sequence of numbers or whatever for use in like counting or bash or doing a thing and many times in a row. Maybe we'll cover them on some other show. We don't really have the time today. We're already past 1 o'clock. Yeah. On our time, Easter. I don't know where you guys are.
So I think maybe we'll use the sequence in probably a bash scripting episode at some point.
Yeah. I use that one a lot for just for loops, essentially, is mainly like, to me, for loops and the sequence command, they're made to go together.
Yep, 100%. So that brings us to the end of our show today. There were some requests for follow-ups. Shantanu, looking at you. So maybe there will be a Bashisms part 2. Right. But it'll be a while. Oh, and yeah, and he just brought up using equal tilde operator inside of double square brackets, which is another reason to use it. But I'm not going to go into that today because we're at time.
Yeah.
Next week, we actually got a comment on one of our videos about bash profiles, RCs, what you do, where, in which one, and how they get executed when you log in. So next week is going to be all about profiles, RCs, variables, environment setup scripts, system-wide environment setup scripts, your personal environment setup scripts. We're going to go through all that stuff.
What order they get executed in. Maybe we'll even talk about what maybe you absolutely shouldn't be doing in those scripts.
Like exiting? I don't know.
Or I don't know, like running services. I've seen that done.
Oh, man.
What? Every time I log in, it starts. It's fine.
There's actually user level systemd now. Just saying.
Yeah, use that.
Yeah, I guess. Okay. And then in 2 weeks, we'll have another show. We're still kind of nailing it down. I had an idea, but we'll see if we actually pull it together and get it done. So next week.
I think we're off next week, aren't we, Scott? I think it's a recharge day. So
okay, how about next
we'll validate
show.
For sure. Next show. There we go.
All right. Thanks for joining us, everybody. Hope you enjoyed some weird bash syntax things. And next show, environment variables, running commands, environment setup.
Awesome. Hope everybody has a great one.